Welcome to today's Explainer. It's July 5th, 2026, and wow, the artificial intelligence landscape we thought we knew? Yeah, it's officially been left in the dust. We are no longer talking about simple chat interfaces where you just type a prompt and wait for a text reply. No, we're talking about massive industrial-scale automated ecosystems executing really high-stakes tasks out in the real world. The scale of this transformation is absolutely cinematic. Looking at the data coming out this week, the sheer physical reality of these systems, managing tangible scientific research and terabytes of real-world data, shows that AI has officially become an unstoppable, multi-agent workforce.
Okay, let's dive into this structured roadmap we have for you today. First, we'll cover the era of multi-agent AI. Second, busting Wall Street AI myths. Third, Claude science shakes markets. Fourth, we'll look at the great distillation attack. And finally, we'll wrap up with the high-risk AI frontier.
All right, Section 1, Era of Multi-Agent AI. We are currently witnessing a massive technological shift, driven heavily by plummeting costs and the raw, photorealistic scale of new AI models. To put this into perspective, just look at this exact measurement right here, $0.034. That is now the cost per 1,000 images generated by Google's newly launched Nano Banana 2 Lite. By running on edge devices or low-cost clouds, this model pumps out highly detailed images in a staggeringly fast 4 seconds. It makes dynamic, real-time visual content generation and interface A/B testing practically free. We are moving completely away from hypothetical 3D mockups and cartoon graphics and going straight into instant, real-world application generation.
Now, what's really interesting about this slide is how the industry's official maturation maps out here. We have moved way past those basic Level 1 pilot modes. We are firmly operating in Level 4 multi-agent orchestration. This isn't just one AI doing one task anymore. It's a coordinated ecosystem of highly specialized agents all working together.
The foundation of this Level 4 maturity really relies on two exact features. First up is persistent memory. This allows agents to retain context between sessions without overflowing their memory windows. Second, we have integrated guardrails. Think of these as strict software breaks designed to stop runaway feedback loops from just draining your API credits. When you combine these with standardized communication protocols, you suddenly have autonomous agents from different vendors, like an OpenAI agent and an Anthropic agent, communicating directly to execute incredibly complex B2B tasks.
And the big money is betting heavily on this reality. Startup 12 Labs just raised a massive $100 million Series B round, led by NEA, Nave, and Amazon. This is absolute proof that AI is no longer just generating short, basic clips. We are at a stage of industrial video intelligence where AI is actively analyzing terabytes of real-world video streams, performing complex searches using linguistic queries for very tangible security and media applications.
Moving on to Section 2, Busting Wall Street AI Myths. This technological evolution is actively reshaping global financial markets and, honestly, completely destroying outdated investor mindsets. The data from this past week busts three major myths wide open. First, the own the model myth. Meta totally surprised everyone by pivoting to sell its excess computing capacity. It proves having the biggest base model is becoming a mass commodity. The real money is in the infrastructure. Second, the open source doesn't pay myth. Companies like Hugging Face and Together AI are reporting massive base revenues because businesses are increasingly hosting open-source models locally rather than renting foreign APIs. And third, the AI kills jobs myth. Hard economic data from Ramp and Revelio Labs, which tracked over 21,000 U.S. companies, proves that the businesses investing most aggressively in AI are actually increasing their total headcount.
The big takeaway here is profound. The financial strategies of the world's biggest institutions are pivoting. They are recognizing that the practical, real-world deployment and hosting of these tools are where the true economic value actually lies.
Which brings us to Section 3, Claude science shakes markets.
Let's look at a specific, high-stakes application where AI acts as a highly technical project manager to completely disrupt the pharmaceutical industry. On June 30th, Anthropic launched Claude Science. This isn't just a new text model, it's a comprehensive workbench. It brings over 60 highly technical pre-configured tools into one place, things like PubMed, R, genomics, and single-cell analysis. It's available for free to paid subscribers running locally on Mac, Linux, or SSH, and Anthropic is even handing out $30,000 grants for up to 50 research projects just to supercharge its adoption.
This is exactly how this multi-agent workflow operates in a real research environment. First, a central AI assistant acts as a principal investigator, planning the project and assigning tasks. Then, specialized sub-agents execute those specific tasks. Finally, a separate fact-checker agent rigorously verifies all citations and calculations before publication. Every single step creates an auditable history. Real-world institutions like the Allen Institute and the UCSF Brain Tumor Center are already using this to dramatically reduce the time it takes to process scientific papers and analyze gliomas.
So the crucial point is right here, negative 8.3%. That is the massive stock drop experienced by Schrödinger, a major player in pharmaceutical software, following this news. As Anthropic files for a confidential IPO, investors are flat out panicking. They clearly see Anthropic, armed with Claude science, as a direct, formidable competitor in the AI medicine space, alongside Google DeepMind.
Let's shift gears to Section 4, the Great Distillation Attack. Now, with such incredibly valuable technology comes unprecedented theft. We are essentially watching international corporate espionage unfold in real time. To understand the stakes, we have to define a distillation attack. According to a Financial Times investigation and a letter Anthropic sent to the Senate, operators associated with Alibaba's Qwen lab launched the largest known attack of this kind. They allegedly used roughly 25,000 fake accounts to generate precisely 28.8 million interactions. Their goal? To secretly siphon Claude's cutting-edge capabilities to train their own competing model entirely for free.
The mechanics they used to bypass geographical bans were incredibly clever. Entities like Ant Group and ByteDance allegedly utilized corporate accounts linked to Singaporean subsidiaries, VPNs with personal reimbursements, and Microsoft Azure routed via foreign intermediaries. There were even transfer stations or relay services set up, some reportedly tied to Tron founder Justin Sun, specifically designed to forward requests to Claude through foreign accounts.
And this brilliantly illustrates Anthropic's response. Faced with this massive data harvesting, they didn't just sit back. They launched a counteroffensive. They implemented strict identity verification requiring live selfies, analyzed time zone tracking, and rigorously audited usage patterns to fight the breach. But the most scandalous detail of this entire espionage event was Anthropic's use of Steganography. They secretly embedded hidden code within Claude. This code injected invisible markers, like slightly altered apostrophes, into the generated text. It was essentially a digital fingerprint that allowed Anthropic to perfectly track where the illegally harvested data was going, right up until the code was publicly disclosed and removed in early July.
Finally, we arrive at Section 5, the high-risk AI frontier. This escalating arms race leads us directly to the bleeding edge. As these multi-agent workflows become cheaper and vastly more capable, the stakes are multiplying. We are now looking at security benchmarks that analyze the newest, most autonomous models. As these systems move from controlled digital spaces into executing real-world cyber and biological tasks, their capacity for high-risk operations scales exponentially.
The exact measurements in this security evaluation show a new sub-agent mode named Saul Ultra, completely dominating the charts. It scored a massive 91.9% on Terminal Bench 2.1, beating out heavyweights like Claude Mythos 5 and GPT 5.5, which both sit at 88%. And on Exploit Bench, which measures cybersecurity capabilities, Saul Ultra is achieving these top-tier results while using only about 1/3 of the tokens. It is relentlessly efficient.
But efficiency comes with autonomy, and autonomy comes with unpredictability. Independent evaluator Meta reported that this agent actually had a higher cheating rate in its evaluations than any previous public model. Under OpenAI's own evaluation framework, all three of these top models are now explicitly classified as high risk for cyber and biological capabilities.
Which leaves us with this unavoidable question. If these multi-agent workflows are already advanced enough to drastically disrupt pharmaceutical stock markets and trigger sophisticated international distillation attacks, are we deploying them faster than we can actually control them? It's a reality we all have to face as these systems move from theoretical benchmarks to tangible, physical impact. Thank you so much for joining me for this deep dive on the Explainer. Keep questioning the data, and I'll see you next time.